Okay, sorry I jumped off camera to do that, but I was getting a little nervous there after the issues I was having with this, and I didn't want to mess up this chassis when we were so close to being totally finished with the fab work. So I marked and drilled 3 holes, and then drilled them out large enough to put this small little grommet in here to insulate the wire. This is going to be, and let me zoom in here. So we have these little grommets, and this is going to be the cathode on each end, and then the center one is going to be for the ground for both of the cathodes. So I'm going to use a little bit of this 18 gauge black wire. So I'm going to cut one nice long piece here that I know is long enough to go over to the star ground point. Even if we're not going all the way over there, I haven't decided yet how I'm going to wire up this little part of the amp. Strip off the end of the wire and bend that over like that. We'll go ahead and stick it through from this side, and we'll do this middle one first. And I probably need to get my little jeweler's pliers and work that through. We're going to solder this whole thing together here. It's going to take a little bit of heat to get this whole thing warmed up enough to solder together. We'll make sure we get this soldered good. And obviously these resistors are used to getting pretty hot, so I'm not worried about soaking some heat into them, especially this joint in the center. And there we go. These side ones are just going to come over here to the tube, so I'm just going to cut a couple of pieces of wire about that long for them. And I keep saying this, but at some point I think this wiring is going to start zipping along pretty quickly once we're done having to fabricate up stuff. But again, like I've said several times, this is a hobby. You shouldn't get all upset if things take a little while. And we should be trying to do this as nice as we can. Actually, I'm not real happy with that. So I think I want to have a little less of the wire sticking out where I bend it over and have it look more like that. There we go. And then solder this one. Again, we want to get this lug good and hot. Make sure the solder is going onto it first before we come down and start soldering the wire in, so we don't just melt all the insulation off the wire. I will say it's been really frustrating trying to work with these little small resistors, and I'm going to not put these in the BOM, and I'm going to find some of the slightly larger size. They're a lot easier to work with, and they're a lot easier to find the hardware for. And just even these little screws and trying to hold on to the little nuts on the back side, and everything's just tiny. And I have to think that the slightly larger size dissipates the heat better. And there we go. They look like that when they're soldered in. And like I said, I think I can come in here and put some epoxy over these exposed leads. And given that it's only 30 volts, I think that'll be safe. I'm not going to be too concerned about that. So anyway, we got those mounted. The wires are all through on the other side, and we're ready to flip the amp over and start wiring up these output tubes. And one last thing real quick I wanted to show you before we flip this over and get to working on the wiring on the underside. That's the size resistor that I've used up until now. As you can see, these are like substantially bigger, and it makes them so much easier to work with. These holes are 440 or 3mm screws, can easily work in. It's because they're a little bigger, it's easier to, get this little angle thing going on. This lip here around the edge is bigger, and so it gives you a little fudge room on the size of the holes. You could actually just drill the holes a little bigger, and then they can wiggle around a little bit to line them up. So these were some eBay specials. I think they were 5 of them for $10. And I'd used up 4 of them, and I only had 1 left. So I ordered these from Mauser in an order. Like I said, I didn't realize they were these almost half the size of these. And while they're rated at 10 watts, and it said they'll handle 5 watts in open air, and we only need 2 watts of dissipation, I can't help but think that these larger size ones with more surface area are going to dissipate heat better, even if they aren't as high a quality. The other option is just go ahead and go to the 25 watt of these Ohmite, or I think Vichy makes the same things in 25 watts that they keep in stock, and they're a larger size too, or kind of overkill, but there's nothing wrong with that, and they're just so much easier to physically work with. These were, obviously from the last video, these are a nightmare to work with. So let's flip this thing over and get to wiring up these output tubes. Okay, time to start wiring up the inside of this amp. So we have our 3 wires here that are coming through from the cathode resistors, and these 2 are going to be going to the cathodes, and this one's going to ground. So I've decided that I'm going to put a little 3-terminal tag strip right here. And let me go ahead and get the most hated tool on the channel and loosen this nut up and put our tag strip in place. And I did want to note the screws that I used to hold down these transformers were a little long. So I came in with my dremel tool and I did cut off the ends of these just a little bit, just to get them out of our way. And I'll come back and hit that with a little black paint so it doesn't rust. So we have our little tag strip in place here, and my plan is to run one of these wires to the bottom hole in this strip, run this other one to the bottom hole in that tag, and then we're going to be running this piece of 14 gauge solid copper, basically is house wiring, over like this, maybe come up a little bit too, go like this, over like that, and then finally turn back over like this, over to our star ground. And you can always straighten these up a little bit and get them a little more at right angles to make it look pretty, but it's going to go like that. And that's going to tie this ground point over to our star ground. Now, I've heard people say, oh, you shouldn't have this bolted down to the chassis or be using this because you've created a chassis ground over here. My feeling is that the electricity is going to take the path of least resistance, which is going to be this heavy copper wire. And while there may be a little bit of parallel current going through the chassis, the vast majority of the current is going to be going through this wire. And I've wired up several amps like this, never had any issues. If you're really concerned about that and you think this is a big problem, no big deal. Use a 4 or 5 terminal strip. Don't use this one, and pick another one for your ground. But like I said, I've wired a bunch like this, hadn't had any issues. So the other thing we're going to be doing here is we've got these 220 UF 50 volt cathode bypass caps. I've bent the leads like this, so the negative ones can be up against each other like that. And these guys are going to sit right there. I need to jump these two together, and so I'm going to make up a little short jumper wire to go from here to here on the inboard, and then we're going to pick up the cathode here, and then we're going to come straight up from the tube to get it away from these heaters, and then come across like this, and then angle over to here. That probably would work. The other thing we could do is come up, over, this way, over, and then to here. And that way we're passing these heaters at right angles. And then we're going to do the same thing over here. We're going to tie these two inner holes together. And then we're going to pull this up, come over, and connect to here. So we're going to connect our cathodes to here. That'll also be connected to our, this is going to be the ground. That's going to be going to one cathode resistor, and then that'll go to the other. So we're going to use this tag strip as kind of the grounding point for everything to do with the output tubes. The other thing we're going to do is we're going to put a couple of 3-terminal tag strips over here on each of these output tubes. And again, I use some fingernail polish to help just keep me straight. The blue is the plate, so this is going to come straight over to here. And then this one will come up and over like that. And remember, we've got a 2-inch deep chassis, so we could loop these things up so they're nowhere near the heater wires. Then I marked the grids with some yellow paint, have the grid stopper super close to this pin, and then bring it over here. That way we've got a point to tie our coupling cap to. Then we're going to connect the grid leak resistor from here over to our ground point. The other thing that we're going to be using this tag strip for is we're going to run the screen that the ultralinear tap wire is going to go to. We'll have it like this. We'll have the screen stopper go between here and this pin, and then run the ultralinear tap wire to here. Again, we may end up using this as like a ground point for our grid leak resistor, and just put it across these two terminals, and then run a couple of wires from both of these center pins over here to our remote star ground point that we're tying to our main star ground with that big fat wire. And so that's kind of our plan. So I'm going to go ahead and install these 2 terminal strips, and they're just going to go underneath this same screw that holds down the tube ring. And given that we're running it through this, I don't feel like it needs the washer anymore. and I want to make sure I get as much engagement in the threads of that tube ring as I can. So that one's going to go right there. And I think, just for fun, I'm going to twist these a little like that so I get some distance between the heater and this terminal. Distance between AC and anything related to the signal path is a win. So we'll do them just like that. I had somebody ask me this question, and I really don't think it makes any difference which side of the grid stopper resistor you put the grid leak resistor. And typically, I've connected the grid leak resistor, that's the resistor that goes between the grid and ground, to reference the grid to ground to get the negative bias on the grid. I typically connect it from the pin to wherever the ground is, and then the grid stopper, I run it from the pin to the coupling cap or whatever the input signal is. So I think I'm going to continue doing that. We're just going to run the grid stopper from here to here, and this will be the tie-in point for the coupling cap. We're going to run the grid leak resistor from here to here, and then pull a couple of grounds together, probably tie them into one wire, and then run it over here to our ground point to ground the grid leak resistors. So let me start getting ready to do all of that. So the next step is connecting the large ground to our 3-terminal strip that we're going to be bolting down here, and we're going to be soldering this big piece of 14 gauge solid core wire to the lower terminal here on this strip. And I think I mentioned before, when we're soldering onto the lower pin of one of these that's bolted, you want to make sure you unbolt it, because the heat's going to sink through this lug to the chassis and not really heat up good. You won't get a good solder joint. So we got this unbolted. We also got our little alligator clip holding fixture here to hold the wire in the middle of that hole, and we're going to solder this ground joint here. It's going to take a little heat to get this thing warmed up good. You want to flow the solder into the terminal first, and then come over to this solid wire. And this is another place. Don't be skimpy with the heat or the solder. I'm going to go ahead and really solder this good. Because this is the main grounding point for our output tubes. Now let that cool off good before you touch it. You don't want to disturb it while it's cooling and end up with a crystallized solder joint there. We end up with something like that. And we may need to trim this off and then maybe get a little of this solder out that flowed down here so we can get the nut back on it. So we might turn it upside down a little bit and let gravity do a little of this work for us. Here we go. Let's see if we got that off for enough where we can get this nut back on here. A tight fit, but it should just go in there. And there we go. And I'm going to flip this up and tighten up the Allen bolt from the other side. And we end up with this right here. So we got a nice, fairly huge ground wire. It's coming over here to our star ground point. Let's go ahead and get these. This is going to be the ground So we know this is going to go to the center terminal here. So let's go ahead and snip that off. Strip this back. And get it bent where we know it's going to go. It's going to sit right there. We're probably going to have quite a bundle of little wires coming into this spot because we're going to have the ground from these two also coming over here. But for now, let's work on, and I'm not sure if I need to really put these into these lower holes, but it's not going to hurt anything to do that. So let's go ahead and snip that one off. That one off. Strip these two back and get them ready to, if we put them in the lower ones, we can go ahead and solder them in place. And we'll just be totally finished with those. I like getting wires just out of the way. Or done deal, or however you want to call it. So we'll go ahead and put that in that lower hole. Put this one in that lower hole. And then go ahead and solder these two in place, and we'll have the resistors sorted out. The other little trick too is, you know, gravity is going to be working on this. So you start at the top of the hole with feeding the solder in, and then the gravity will pull it down towards the bottom. And then you take the heat off. Okay. So the next thing we need to figure out is, let's deal with these cathode pins on the tube sockets. So we want to put a jumper wire between these two holes here, and then run a wire from here up, over, into this pin. So first, let's do our little jumper. We're going to cut a piece of wire off that's a little longer than between those two holes. But it's actually easier if we know we're going to be using a bare piece of wire, to go ahead and strip off the insulation for the whole piece we're going to use. Like that, then cut it off. Then come in here and bend one end over like that. Let's try maybe holding it like that. We need to bend it right where I had the pliers. So I'm going to bend that over and make a little U-shaped piece like this and set it down in those holes like that. And I might as well go ahead and make another one of those, because we're going to need one for this other side. Again, there's multiple ways of doing this. You might want to just have the same piece of wire jump off between both of them. But I like making these little U-shaped jumper loops and putting them between those two that I know they're connected, and I just solder the wire onto the other pin, and everything's all connected together. Okay, so we know we're not going to use the outer pin on this, or the outer hole on that pin. So I'm just going to go ahead and cut that off. And cut that one off. And we'll set this little jumper across there. And solder that in place. In most power output tubes, these two pins are connected internally in the tube, and it doesn't need this jumper wire like a KT88, but on an EL34 they're not. So, and it doesn't hurt anything for these two pins to be connected if you do use a tube that has these pins internally connected. But obviously, if you need them connected and they're not, the tube won't work right. Okay, so now we have those two pins jumpered together. So I hope you're enjoying this series. If you are, please subscribe to the channel. Please like the video. And I'll see you soon for more 6SQ7 fun. Have a great day.